All right, so let's take a look at this density paper that we got going on. The first part is just setting up your density equations and making sure you know how to use them. So I'm always going to give you this triangle. Always, always, always. So density is equal to, so if I give you this, that means you're looking for this and this. It's mass divided by volume. So mass divided by volume. If I give you this, if you're looking for this, that means it's mass divided by density. If you're looking for mass, then it's density times volume because they're next to each other, across from each other. So density times volume, like that. All right, what about the units for mass? Anytime you see grams, you're working with mass. What about volume? Anytime you see ml or cm cubed, it is volume. Remember, 1 ml is equal to 1 centimeter cubed. Same thing. It's like $1 is equal to 100 pennies. You can switch them back and forth. Now for density, it is the gram per ml or the gram per centimeter cubed, like that. So this is just some conceptual stuff for you to think about without the use of a calculator. Most of you could do this just fine when I'm talking about people and rooms or dollars and people. And then we switch it over to words like grams or milliliters, and people often kind of lose track of what they're doing. So look, if you have 10 people in 2 rooms, you divide it equally. How many people fit into each room? Well, you could put 5, terrible 5. Put 5 people per room, right? Most of you can figure that out. Now, what happens if I have 3 rooms, 10 people in each room? How many people are there total? Well, okay, well, there's 10 in room 1, 20, and 30. Well, then there's 30 people. Notice how I'm putting a unit. If it's just a number, it's wrong. What about this one? You got 8 people, and you put 2 per rooms. How many rooms you got? Sorry about all that racket on the outside. I'll let it pass. So you have 8 people total. You have 2 people per room. How many rooms would you have? Okay, well, I know there's 8 people, and there's 2 people in each room. So 2 in the first one, 4, 6, 8. Well, that means I must have 4 rooms, like that. Most people can get through that problem. All right. See, and now we switch it over to this, and then it's like, I don't know how to do this. Look, you have 10 grams and 2 mLs. If you divide it equally, how many grams are in each ml? So look, I have 1 ml, I got 2 mLs. Drawing sometimes helps out. So 1 ml, 2 mLs. So actually, so 1, 2. If I have 10, how many are in this one and how many are in this one? Look, it's just like the people example. Well, that must mean I have 5 here and 5 here for a total of 10. So how many grams are in each? 10 grams in each. Okay. Here it's saying, look, you have 3 little blocks. You got 1, a 2, a 3. And each one weighs 10 grams. So this weighs 10, this weighs 10, and this weighs 10. How many grams do you have in total? 10, 20, 30. I got 30 grams. Each one weighs 10 grams. Last one. You have a total of 8 grams. So when I add this together, I get 80 grams. And it says that each little block weighs 2 grams. Oh, sorry, this is 8 grams, not 80. Sorry, 8 grams. So how many blocks would I need to make 8 grams? Okay, well then I need 1 box. This weighs 2 grams. I'm not there yet. 2, 4, 6, 8. So how many blocks would I need? 1, 2, 3, 4. If each of them weighs 2 grams. So I would need 4 centimeters cubed. That is the name of this little block right here. The centimeter cubed. All right. So now we come over here. Again, no calculators. Just working straight from your brain. Calculate the density. So this one I've helped you out by letting you know, okay, we're going to be looking for this. But get to the habit of looking, look, okay, I got 20G. That means that it is mass. How do I know that? Look, anytime we're talking about mass, you're going to see the G. This is 2 centimeters cubed. Look, anytime you see this by itself, we're talking about volume. So this is 2 centimeters cubed, like that. So I'm going to set these up first, and then I'll come back and solve. So student finds a rock, but listen, For most of these, you don't even need to read the problem. You got this, and you got this. You got 80 grams, or sorry, 8 grams. Yeah, 80 grams on this one. That goes into mass. Again, I don't even have to read the problem. I just look. Yes, I should read the problem, but like sometimes the variables are there. And it says the volume is 40 centimeters cubed. Okay. Down over here, look, I got grams. I know that's mass. So listen, the first number is not always mass. Like this one, look. The first number we run across is volume. Okay, first number we run across here, mass. This, the unit tells me what we're working with. All right, 30 mLs. ml means volume. So this is 30 mLs, like so. Okay, now I can set up my problems. Look, I'm looking for density. So density is mass divided by volume. So it is 20 divided by 2. This one is 80 divided by 40. Notice how I set it up before I started doing all the work. And then this one is 30 grams divided by 30 mLs. Grams, centimeters cubed. You could even write mLs here. Like this is centimeters cubed, but look, this means the same thing. All right. So 20 divided by 2, it is 10 what? Grams per ml. 80 divided by 40 is equal to 2 grams per ml. So here's what it means. For this fake substance, whatever this fake substance is, it means one of these, if I pulled one of these out, it would weigh 2 grams. For this one, if I pulled one of these squares out, it would weigh 10 grams. Now we can compare the two. So which one is more dense? If this block weighs 2 grams per ml, and this one weighs 10 grams per ml, same size, it means there is more stuff inside of this little cube compared to this one. So this one is more dense because obviously, look, it's the same size, but there's more stuff packed into this cube. All right, what about this last one? 30 divided by 30 leads to 1 gram per ml. Or you can write it as 1 gram per centimeter cubed, like that. That means that this one, this substance, one of these little cubes would weigh 1 gram. All right, over here, I'm going to identify variables, gram and ml. So mass is 12 grams. Volume is 2 mLs. That means that I am looking for density, which means I will use this equation. From here on out, I will let you take care of that. Let's flip it over to the back. The object is ml and gram. So again, volume, I'm going to put 4 mLs here. And this is 24 grams. At this point, I fully expect you to use a calculator. We're looking for density. Here we go. 10 grams per ml. So this one, when I see gram per ml, now I'm looking at density. So in this problem, I have given you density. I've given you 10 grams per ml. And I've given you a mass of 20 grams. That means for this problem, I am looking for volume. And now you use a slightly different equation. For volume, it is mass divided by density. So again, don't plug and chug numbers. Don't say 10 divided by 2. You have to take the mass divided by this to get the volume. And the volume will be in ml or will be in cm cubed. All right, so object's volume is 10 centimeters cubed. So 10 cm cubed. I know that because of the unit. Grams, this means mass. So I have 30 grams. That means I'm looking for density. Here, I have grams and I have density. So that means that this is 10 grams. This is density. So 0.5 grams per ml. Like that. Here's what you can think about like this too. I'm asking how many cubes of oil. Okay, how many cubes of oil are there? That's what volume is. How many of these? Okay. Density is how heavy is one of these. Mass is just how heavy are all of them together. So in this case, since I'm looking for volume, I'm looking at how many cubes are there. So this one I'm saying, look, yes, you can calculate. I'm just showing you how this works conceptually. The total is 10 grams, right? If each one of these weighs 0.5 grams, how many would I need to get to 10? So that's like half a gram, 1 gram, 1.5 grams, 2 grams, 2.5 grams. Again, you just keep adding until you get to 10 grams. In this case, you would need 20 of them because each one, like, if this weighed 1 gram per centimeter cubed, I would need 10 of them to have 10 grams because it means that one of these weighs 1 gram. This weighs half a gram. So look, in order to have 1 gram, I need 2 of them. Half plus half equals 1. So I would need 20 in total of these. I'm going to skip the one over there just because it's off screen. This one is like the flask problem that you had. And if you remember way back when, you're going to love this because you're going to do it again. You had the flask. We also did it as a vial. So I don't know if you remember, we had a vial with green liquid inside of it, and then we had a vial that was empty. The problem with trying to get the volume of just the glass or just the plastic is the air bubble. I don't know if you remember. So what this is saying is, look, you have a soda bottle, a 2-liter soda. That's a terrible 2-liter soda bottle, okay? And it's closed, and you dunk it in water, and it pushes up 2,050 mLs of water. You got to remember, there's 2 things pushing up the water. There is the air inside and the plastic. You want the density of just the plastic, okay? So you have to figure out, okay, out of this, how much of it is air? And there's a way to figure that out. It's not a guess, so don't guess what this is. This one I'll also let you figure out on your own. So just a quick walkthrough of this paper.